Let's get right into it. Number 10. The twin who stole time. You have an identical twin. You both start out exactly the same age, down to the second, but then one of you hops into a spaceship and takes off at nearly the speed of light. When they come back, they're younger than you. This isn't science fiction, it's actual physics. It's been proven to work in real experiments. The faster you move through space, the slower you move through time. Einstein figured this out, and it changed physics forever. When your twin is zooming through space at incredible speeds, their time literally slows down. From their perspective on the ship, everything seems normal. But back on Earth, you're aging faster than them. Scientists tested this with super precise atomic clocks. They put one clock on a plane and flew it around the world. When it landed, it was a tiny bit behind the clock that stayed on the ground. Your twin in the spaceship would actually see your time moving slower from their perspective, but when the traveling twin turns around to come home, they experience an acceleration that the Earth twin doesn't. This turnaround breaks the symmetry and proves the space traveler really does age less. If your twin took a trip at 99.5% the speed of light for what felt like 1 year to them, they'd come back to find you've aged 10 years. Your twin literally stole 9 years of time. We could actually do this if we had fast enough spaceships. It's like a one-way time machine to the future. Number 9. The observer's curse. Reality gets shy when you look at it. Just like a friend who only dances when no one's watching, the universe acts differently when it's being observed. Scientists discovered this through the double-slit experiment. You shoot tiny particles at a wall with 2 slits in it. Behind that wall is a screen that shows where the particles land. When nobody's watching these particles, they do something impossible. They go through both slits at the same time, like a single ripple in a pond passing through 2 openings. But when you put any kind of detector to see which slit the particle goes through, it suddenly acts normal. It picks one slit and goes through it like a regular object. The act of observing forces it to pick a side. This isn't just a lab trick. This is how reality works at its most fundamental level. Everything in the universe exists in multiple states at once until someone observes it. It's like the universe is running a simulation, only rendering the parts we're looking at. Even Einstein couldn't accept this. He said he refuses to believe that the moon only exists when someone looks at it. But at the quantum level, that's exactly how things work. Reality itself depends on whether someone's watching it or not. Number 8. The Bootstrap Paradox. Imagine being a huge fan of a song, and the first thing you do when you invent a time machine is go back to meet the artist who wrote it. You travel back to before the song was released, find the artist, and discover they're struggling to write their next hit. Being the helpful time traveler you are, you show them this amazing song you love. The artist loves it so much they decide to record and release it, and that song becomes the very same hit that you fell in love with in the future. But if you gave them the song, and they didn't write it, who actually created it? The artist didn't write it, they got it from you, but you didn't write it either, you got it from their future self. So this song just exists. It's trapped in an endless loop, being passed back and forth through time, but was never actually created by anyone. The same could happen with Shakespeare's complete works, traveling back in time and giving them to Shakespeare before he wrote them, or giving Einstein the theory of relativity before he came up with it. The information just exists in a loop, with no beginning and no end. Scientists have actually studied this paradox seriously, trying to figure out if it breaks any laws of physics. Surprisingly, they found that this kind of loop might actually be possible according to Einstein's equations. Number 7. The cosmic loneliness problem. Our galaxy alone has more stars than all the grains of sand on Earth, and most of those stars have planets orbiting them. That's like having 1 trillion houses in your neighborhood, but every single one is dark and quiet. The universe is really, really old. If the universe was a person, Earth would be younger than their breakfast. That means if aliens exist, they've had billions of years to develop technology and spread across space. They should be everywhere by now. Humans went from inventing planes to landing on the moon in just 66 years. That's shorter than a TikTok trend in cosmic time. There's this idea called the Great Filter. Life is like a really hard video game with multiple levels. Level 1. Simple life forms appear. Level 2. Complex life evolves. Level 3. Intelligence develops. Level 4. Technology advances. Level 5. Space travel becomes possible. But what if there's a level that's almost impossible to beat? Maybe we're the only ones who've made it this far. Or maybe we haven't reached the hardest level yet. Maybe every civilization that gets to where we are ends up destroying itself. What if we're first? What if we're the advanced aliens that future civilizations will look for? The universe might be full of life, all of us just ghosting each other across the vastness of space. Number 6. Peto's Paradox. The blue whale is nature's way of saying, your logic means nothing to me. Cancer works like a lottery. More cells means more chances for something to go wrong. These massive creatures have about 3,000 times more cells than humans. That means they should be getting cancer roughly 3,000 times more often than we do, but they don't. In fact, whales barely get cancer at all. Scientists call this Peto's Paradox, named after Richard Peto. They looked at elephants, which also don't get much cancer, and found they have extra copies of a cancer-fighting gene. But when they checked whales, they found nothing. These ocean giants are using some other trick, and we have no idea what it is. Some scientists think whales might have hypertumors, tumors that get cancer. These tumors might actually help by stealing resources from the main tumor, like pirates fighting over the same treasure until nobody gets rich. Other scientists think whale cells might just be really lazy. They divide slower than our cells, which means fewer chances for things to go wrong. Understanding how whales dodge cancer could help us treat human cancer. Number 5. The ship of you. You're not the same person you were 7 years ago. Almost every cell in your body has been replaced. Your skin is new every 2 to 3 weeks. Your liver is brand new every 6 weeks. Even your skeleton gets completely rebuilt every 10 years. This is called the ship of Theseus paradox. Imagine you have a ship, and over time you replace every single plank, every nail, every rope. Once you've replaced everything, is it still the same ship? Now replace ship with you and planks with cells. Your body is doing this replacement right now as you watch this video. Your brain cells are the only ones that stick around for your whole life. But even they're not stable because your brain is constantly rewiring itself. Your memories from yesterday are stored differently than they were when you made them. When you remember something from your childhood, you're not actually remembering the event. You're remembering the last time you remembered it. Each time you recall a memory, you slightly change it. That embarrassing thing you did in 3rd grade might be completely different from what actually happened. Your brain has been gaslighting you your entire life. Number 4. The Monty brain melter. You're on a game show with 3 doors in front of you. Behind one door is a brand new car. Behind the other 2 doors are goats. You pick a door, let's say door number 1. The host, who knows what's behind each door, opens one of the other doors you didn't pick. He always shows you a goat. Then he asks if you want to switch to the other unopened door. Most people think it's now a 50-50 chance between the 2 remaining doors. But they're wrong. If you switch doors, you have a 2/3 chance of winning the car. If you stay with your original door, you only have a 1/3 chance. Here's why. Imagine there are 100 doors. 1 has a car, 99 have goats. You pick a door. Then the host opens 98 other doors, all showing goats. When you made your first pick, you had a 1/100th chance of picking the car. That means there was a 99/100th chance the car was behind one of the other doors. The same logic applies with 3 doors. When you first pick, you have a 1/3 chance of picking the car. That means there's a 2/3 chance the car is behind one of the other doors. When the host shows you a goat, all that 2/3 probability moves to the last remaining door. This paradox was so mind-bending that even PhD mathematicians wrote angry letters saying it was wrong, but you can test it yourself. Play the game 100 times switching doors and you'll win about 67 times. Play without switching and you'll only win about 33 times. Number 3. Spooky action at a distance. Imagine you have 2 identical pairs of gloves. You put one glove in a box and send it to your friend on Mars. You keep the other glove on Earth. Without opening either box, you already know that if your glove is a left-hand glove, your friend's must be a right-hand glove. That's how quantum entanglement works, except way weirder. Instead of gloves, we're talking about tiny particles that are linked in a way that breaks our brain. When you look at your particle, its partner instantly knows and reacts. Not in a few minutes, not in a few seconds, but instantly, even if that other particle is on the other side of the universe. Einstein called this spooky action at a distance because it seemed impossible. It's like having 2 coins that are always opposite of each other. If you flip one and get heads, the other one instantly becomes tails. Even if that other coin is in another galaxy, there's no tiny phone line connecting them. They just know. Scientists have separated entangled particles by miles and watched them react to each other faster than light could travel between them. We use this weird quantum magic in real life. Quantum computers use entanglement. Super secure encryption uses entanglement. The universe is running on code that doesn't follow our rules, and we still don't really know how it works. We just know that it does. Number 2. The Peto Paradox. Imagine you've got 100 pounds of potatoes that are 99% water. Now you let them dry out just a tiny bit until they're 98% water. The potatoes now weigh 50 pounds. Half the weight is gone from just 1% less water. Here's why this works. In those original 100 pounds of potatoes, only 1 pound is actual potato. The other 99 pounds is just water. When the potatoes become 98% water, that 1 pound of actual potato must be 2% of the total weight. So if 1 pound is 2% of the total has to be 50 pounds. Think about it like a party where 99% of people wear blue shirts. If one person in a red shirt is 1% of the crowd, there must be 99 people in blue shirts. But if that same person needs to be 2% of the crowd, there can only be 49 people in blue shirts. If you dried these potatoes to 97% water, they'd weigh about 33 pounds. At 96% water, they'd weigh just 25 pounds. Sometimes the smallest changes have the biggest impacts. Number 1. The time crystal glitch. Time crystals are like regular crystals, but instead of repeating patterns in space, they repeat in time. They are always moving in the same pattern, without using any energy. Everything in our world needs energy to keep moving. But time crystals found a way around this rule. Scientists created them in 2016. They took atoms, cooled them down until they were almost completely still, and zapped them with lasers. These crystals aren't breaking physics. They're using quantum rules instead of regular ones. In the quantum world, things can be in multiple places at once, and particles can teleport through walls. It's like finding a video game glitch that lets you jump infinitely without losing stamina, except this glitch exists in real life. Scientists think time crystals could be crucial for quantum computers. These computers could solve problems that would take regular computers millions of years. That's all for today. I'll be making similar videos in the future. Subscribe to see them.